All right, so we really want to take our knowledge of graphing lines and use them to find what inequalities would look like on a two-dimensional graph. You know what inequalities look like on a number line, right? You know how to, draw a line and say, oh, we want an open circle on 5 and an arrow to the right, or maybe on 3 and we want a closed circle and an arrow to the left. So you've done those kind of things on number lines. That's a one-dimensional. Now we're talking two-dimensional. All right, so an X and a Y. And we want to say, okay, well, what does a solid dot look like for a line, and what does an open dot look like for a line? And then what is this idea of shading, and how does that apply to a graph? Well, these are called half planes because you're really taking half of the entire graph. That's why we're going to be doing shading. So yes, we will throw some shade. That is true, folks. Not even kidding. So let's see here. Fill some shapes there. And this one obviously has a y-intercept at -7. We talked about the y-intercept in section 12, and then using the slope to find other lines, up 5 and to the right 2. You got to be able to look at that slope. So yeah, we got our y-intercept there and at -7, and our slope, which does mean up 5. And always, I like it when people go to the right first, at least when they do their first coordinate. So that the top tells you up or down, and the bottom tells you to the right. And so let's see here. So up 5 over 2, and up 5 and over 2 again. So this gives us the idea of where our line's going to go. Now, how do I notice that this one is not equal to. Not equal to, all right? So, whoa, that is not what I want. Not equal to. So I can't draw a solid line. So we have to do something called a dashed line. And so when I draw my line here, it's going to go right through these points. We're going to draw a dashed line instead of a solid line. Okay? Now, it still goes on forever and ever in both directions. We are interested in knowing which side of the line to shade. And we can plug in points until we figure it out. It wouldn't take us that long. We just have to plug in one point on either side of the line, whichever side we want. But we don't actually have to. All right, so let me type something out here. If the y value, if the y is on the left side, and that's kind of key right there, then it's either up or down. Up or down. Now you're probably looking at me going, well, wait a second, what do you mean by up or down? This isn't exactly a horizontal line. Okay, so here's what I mean by that. I will actually draw a little tiny arrow above the line that goes up, since this is a greater than sign. And since y is greater than the line, then that means we want all the y's. So we could immediately shade all these points if we wanted to. But I'm going to suggest not, because it gets kind of messy. Well, okay, now wait a second. I should say that would be true for a system of equations. That's what we're going to get to next. So if you're just doing one, like this one, then yes, you would shade on that side of the line, and that is the graph for that particular, because there's only one inequality. And of course, we know it continues up above and out here and all that good stuff, but we're not going to keep drawing all that stuff. We'll stick to the graph, and just everybody knows that that's where, So these points over here, these points are called solutions. So right down here it says, give an example of a solution. So any point in there, there are billions and trillions of them, Kids today said 0, 0, and some other smart aleck kids said -6, -7, which is kind of funny currently with the culture and that song that I heard that was really, really ridiculous. But anyway, probably won't make sense in about 10 years. Let's see. Now, what happens when we talk about graphing a system of linear inequalities? So eventually, what are we going to see in the next couple examples? Well, we might have a line that looks like that, and we might decide that we're going to shade above that. And then we might have another line, and that one's going to be a solid line, and we might say, oh, we're going to shade below that. Okay? Maybe those are the decisions we have to look at. Well, when we get to a situation like that, I'm going to be labeling sections 1, 2, 3, 4. Okay? And then we have to decide which one of the sections is the right one. Now, there's nothing magic by the way that I labeled those. It's just so that, I could shade above the purple line, I could shade below the blue line, and have this massive thing. I mean, literally, I could go, oh, yeah, let's do all of this. And let's do all of this. It gets really, really ugly. The key thing is we want to figure out of 1, 2, 3, and 4, which one is where they both overlap. And so the key is just finding that one right there, and I just want to shade that one. So in my example, number 1, okay? So that's the kind of thing we want to do. We want to find the overlapping region where all the solutions are. Now, if you want to cover it up with your hand, and say, oh, okay, well, it's all of this half of the line, it's all of this half of the line. Oh, well, that overlaps in section 1. That, if that helps, literally take your hand and cover the half of the graph that you should shade, and then do it for the other one and see where they overlap. For instance, on example 1 here, you can see I went ahead and graphed the first one in red, y-intercept at -1, with a slope of -1. And so you can see that I found -1, and then I went down 1, right 1, down 1, right 1, down 1, right 1. You can do that for a ways. There is no equal sign. The equal sign is what causes the line to be a solid line or a dashed line. Okay? So equal sign is a solid line. And if I have a less than or a greater than, I get these dashed lines. Okay? Well, the other one, the one that I colored light blue, is also not equal to, so it's a dashed line. It has a y-intercept of -3 and a slope of 2/3, so I went up 2 over 3, up 2 over 3. And we drew that line right there. So the question is, which one of those? All right, so let's see here. Since I've got the blue pen pulled up here, we want below. According to the line right there, it says below the blue line. Okay, so below. I'll put a little arrow there. And now we're doing the red one, and it wants above the red line. So which section? Use your hands if you want to. So in your mind, I know you can't see me doing this, but I'm just taking my right hand and I'm covering above the red line. Okay, and then I'm taking my left hand and covering below the blue line. And then I see in my mind where it crosses. And obviously, it's crossing over here at section 3. That's all the harder it gets. Well, yeah, I guess we can get some interesting situations, but not very many. Okay, so on my next one. Let's see here. We got -6, so that's down 6. Put a dot. And the slope is -3/2. So that would be down 3, which is just off my graph, and over 2 to the right. And the reason I want you to do one coordinate, even if it goes off the graph, is so that when you start to go backwards, you don't mess up the slope of the line. Some kids like to do that. Now, this particular one does have an equal sign on it, so we will have a solid line. Okay, +5. Slope is -2. Remember, that's -2/1. -2/1. So when I do this, I would go down 2, right 1. Down 2, right 1. Down 2, right 1. And so this gives us the idea of that. There's no equal sign on that one. So we'll go dashed lines. Change to a line. Oh, yeah, I got to take off the dashed lines part. Okay, so the orange one, which is the second one, is less than, shading less than. That would be below. And the red one is greater than, so that shades above. So where do they overlap? Right there in the middle. Now, you may at first think that that is like a river with banks that are parallel on both sides. But those lines are not parallel. Eventually, way down off the graph that I have drawn, to the bottom right corner, they're going to come to a point. So they will have, it is more of a triangular shape, not some sort of, parallel line type thing. Give examples of solutions. Obviously, all we need to do is pick something that's over in the shaded region, like 6, -2, 0, 0, anything that's in the shaded region. I could have picked -2, +3, or something like that. Anything that's in the shaded region would work. So they just want one example. That's all. Something that actually will fall in the shaded region. Now, what happens if you pick a point that's outside the shaded region? What happens on the inequality? Well, you would find out that you would get a false statement. If you actually did the algebra of that. Okay, a couple more situations. These are a little bit less obvious. Remember that x equals a number. That is a vertical line. And a lot of people don't remember that. So we should have, for the first one, a solid line. X is greater than or equal to 2. So that is going to look like this. And greater than would be to the right. And then we can graph the other one, which is x is less than or equal to less than, but not equal to -3. So that's going to be a dashed line at -3. Whoa. Freehanded it. Let's not freehand it. I don't draw very good lines if I freehand. Sorry for yawning so much. I know that gets really annoying when you're trying to take notes and trying to do them at night, and you're like, Mr. Stailey, why are you doing that? So x is less than -3, smaller, that would be to the left. Okay? Remember, these inequality answers are going to be about where the two graphs cross. Where do they overlap? They don't in this particular case. So the answer to this question is no solution. Hopefully that makes sense. So in this one, we have at 5, so this is a horizontal line. It's going to be a dashed horizontal line. Oh, look, I can freehand that one. It's going to be y is smaller than that, so it's shading below. Here we have x is greater than or equal to 0. That's another vertical line. Greater than, ooh, I did something wrong. Equal to solid line. Okay, now greater than 0 would be to the right, and so we can see where they want us to shade. Out here. Okay, now, what if it gets a little more complicated? I probably would solve these equations for y. I think that would be easier for everybody. So move the 4x over to the other side. So 3y is greater than, since you're subtracting 4x, that would be negative 4x plus 24. And you would divide by 3. Y is greater than negative 4/3 x plus 8. And then, of course, you do the same thing with the next one. You'd subtract that over, and you'd get negative 4y is less than or equal to negative 6x plus 12. Then we can divide by the negative 4. So that's y, and it's going to flip the sign. You divide it by a negative number, so don't forget to flip the sign like you always do. Now 6 over 4, that reduces to 3 over 2. And 12 divided by negative 4 is negative 3. All right, so let's do my first one here in red. We got positive 8 and down 4 and over 3 and down 4 and over 3. That is going to be a dashed line without dashed line, no solid line. And then greater than would be up. Okay, let's do the next one. So we got minus 3. And then we want 3 over 2. Up 3 over 2. Up 3 over 2. And so this one happens to be a solid line because of the equal to. And it wants greater than, so we want to shade above. So if you kind of use your hands and shade that one above the red line and that one above the orange line, you can see out of our choices of 1, 2, 3, 4, that it would have to be choice 1. Okay, Malcolm earns $20 per hour mowing lawns and $10 per hour walking dogs. His goal is to earn at least $200 each week, but he can work a maximum of 20 hours per week. So, right there is an equation. He can work a maximum of 20 hours per week. That's the number of hours that he gets for mowing and the number of hours he does dog walking is a total of 20. That's what I got from that information. Now, at the beginning, it said Malcolm earns $20 for mowing a yard per hour for mowing a yard. So 20 times X plus 10 for each hour with a dog. It's kind of wild. I mean, $10 for an hour of being with a dog, taking care of it. Um, his goal is to earn at least $200. At least $200. Oh, I forgot something in my last question, or my last equation. It said a maximum. So that means less than or equal to. Okay. I should probably graph some of these, and y is less than or equal to negative x plus 20. So I just took the x and moved it to the other side. So you can find the 20 and you know that it's down one, right one, down one, right one, down one, right one. So, boy, I better not freehand this one. I better get some good old dots on the graph and draw a line. Good line. All right, let's go to the red and solve that one. So we're going to move the 20x to the other side. Oops, got to scribble back on. 20x to the other side, that's 10y is greater than or equal to negative 20x plus 200. And then we divide everything by 10, which gives us y is greater than or equal to negative 2x plus 20. Well, that must mean you've got a y-intercept there at 20. And an x-intercept and so we can draw this line. Now, the red one, we're going to shade above the line. And the purple one, we're going to shade below the line. So you might think that's all we've got, but I think there's more information to look at. Malcolm must spend at least 5 hours per week walking his neighbor's dogs. So y is the number of dogs, so they just told me that y has to be greater than or equal to 5. Well, y equals 5 is a horizontal line that comes through here like this. And we want to shade above that line. Okay. If you put all three of those things together, then you get this small little triangle section. And that's the overlap of those. So any number, any combo in that shaded region would be a solution to this system. So there's lots of choices. All right, that's enough notes for this section. Thanks. See you at school.